Okay, so welcome to question 7 on the 2015 paper 1. Now it's the first question of section B. So section B questions are worth more marks. This one here, question 7, is worth 70. I know this question before and it's going to take us some time. So batten down the hatches. Again, as always, look, you need to try it yourself first. This part A, so let's read it from the top. The first 3 patterns in a sequence of patterns are shown below. So you see there's 1 white triangle, 3 blacks, 3 whites, then 1, 2, 3, 4, 5, 6 blacks, etc. Okay, so there's a sequence going on there. Now, what is the sequence? Let's identify 1 becomes 1, then there's 3 of them, then 1, 2, 3, 4, 5, 6 of them. The blacks, there's 3, then 6, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that's doubling. 1 becomes 3, becomes 6. Okay. So the pattern, the next one should be going up by 1, 2, 3. No, I should be sure. I have the answer on the next page. It's been a while since I've seen it. 1 up by 2, 1 up by 3. Okay, the next one's probably going up. Okay, just 1. The difference there, I suppose, is 2. The difference there is 3. If that pattern holds was going up by 1 each time, the next one should be going up by 4 and should be 10. Okay, for the white triangles. Okay. The black started off as 3, going up to 6, going up to 10. Okay, so what's the next one? Difference of 3, then a difference of 4. So I'm assuming that's a difference of 5, so the next one there is 15. Okay, so if you identify the pattern, that's cool. Now, I've actually, apologies, sorry to pause there for a second. Let's have a little chat with my lovely daughter. Wanted to play all of a sudden. So what I've done is, okay, I've just not read the question properly, which is a flaw of mine, and I suppose learn from my mistakes. Always read the question. So all I do is draw that shape. So if you follow the pattern up, 2, 3, 4, the next one's going to have 5, okay, 1 white, 2 whites, 3 whites, and then 4 whites. So I suppose it's much easier. I think I'll have to draw that sequence or work out the pattern for the next one anyway, so I've saved myself work in part B. But that's part A. Now, 15 marks. That's a B scale, so it jumps from 0 to 3. So any correct drawing of even the big triangle, I'm sure will get you the mid partial there of 3. But what a jump of marks. 12 marks to get to the actual correct answer. If you lose that by something, it's a terrible loss of 12 marks. Okay, it's like 2% of the exam. Okay, so let's go on. Here was their action. They give you the first pattern. Okay, 3 blacks, 1 white, 4 triangles in total. So we said our pattern 2 was, what did we say? There was what? 3 whites, 6 blacks. So let's just go to the answer. 6 blacks, 3 white. There's 9 in total. Pattern 3, which you were given. 10 blacks, 6 white, and 16 triangles in total. I worked out 15 in the mistake in part A, but I've done it there. If you see now the pattern going up by 2 plus 1. Okay, this is 3 plus 1. This is 4 plus 1. This is 5 plus 1. Next one will be 6 plus 1, etc., etc. This one's going up by, so 2 plus 1 is 3 plus 1 is 4 plus 1 is 5. Okay, so there's going to be a pattern here, but, oh yeah, they're all, if you look at them, they're all square rootable. Okay, so that I think that comes in handy later on. Always be good to be thinking, if you see something that's relevant, you think it's important, just write it down on the page. You never know when that piece of work will get you the attempt, or like marks. We're like, in a sense, it should be noted that in the exam we're kind of looking to give you marks. So if you make things, make leaps of thought, you deserve credit for that. So if you don't write that down, we'll never know. If you do write that down, we can give you and reward you for that thought process. So part C then, okay, show that the numbers of black triangles form a quadratic sequence. Now, this is a new thing from Project Maths, but when you differentiate something, Okay, it drops down. So you see, if you had a third order polynomial, which is like a cubic equation, and you differentiate it, you get a second order, which is quadratic. You differentiate that again, you end up with a first order, which is linear. You integrate linear, you end up with a constant. So it's always dropping down. Okay. Now, that's a kind of linked to this concept. But if the first difference, I suppose actually, ignore the first difference. We're looking for, it's the second difference of the numbers. So if you break down 4, 7, 12, 19, 28, this is an example. The difference between that is 3, 5, 7, 9. The difference between those numbers. Now, the difference between the numbers, the first difference is constant. Okay, it's 3, 5, 7, 9. That's a constant difference that indicates that it's quadratic. Okay. Now, I don't know in an exam, without having come across this question before, if I get that. It's kind of, I suppose, I won't say it's high-level thought, it's just, I wouldn't be expecting it. But it's twice they've asked that now in the last 3 years, so whether that means they're done with it, or they're going to ask it again and again, is just impossible to know. I'm going to go give the answer there. So I've shown that here from the actual example we have. So it was 3, 6, 10, 15, 21. Okay. The difference between them is 3, 4, 5, 6. That was the pattern we identified. Now the difference between the pattern is 1, 1, 1, whatever. So that's the second difference, is a constant, therefore quadratic. Okay. Now, we do it here part D, part 1. Okay, so how many black triangles are in the 9th pattern? Okay, so I just kind of kept the pattern going. Okay. I could have given the actual numbers, but it's going up by 7, then 8, and then 9, and then 10. So you can just add those numbers. And the number of black triangles in the 9th pattern will come out to be 55. Same with the white one. You're finished off on the 5th one. It's going up by 6, and then 7, and then 8, and then 9. Okay, so you can add them on. And that's going to be 45. Okay. That's part B, part 1 and 2, and then part 3. How many small triangles in total are in the 9th pattern? We're going to be adding the 45 and the 55. Okay. And that gives you your 100. So each part follows on. Now let's say, I suppose if you copped that if you knew that the black and white there together were going to add to give the total, but you couldn't figure out what they were, make up an answer here. If you add those two made up answers, you could have went 2 and 2. Okay, and given 4 as the answer of part 3. That answer in part 3 would be accepted as fully correct based on your answers, your shown answer, shown answers in part D and 1 and 2. So there was, if you're having a bad day, a get out there. Now let's do part 3. So move on. Okay, so write an expression in N for the total number of triangles in the nth pattern. Okay, so now these two questions are being tough. I'm going to flick off the answer. I've gotten this here, okay, from the maths tables, okay. Suppose in a sense, write an expression in N for the total number of triangles in the nth pattern. If you go back and look at it, it's the ones here now. I know I've messed it up a little bit, but 4, okay, is the same thing as the N plus 1. So 1 plus 1 is 2. And square that. Okay, so the fact that they had a pattern that they're all square rootable is the trick here. 2 plus 1 is 3. Okay, and square that, you get 9. 3 plus 1 is 4. Square that, you get 16. 4 plus 1 is 5. Square that, you get 25. 5 plus 1 is 6. Square that, you get 36. So that's the pattern going on there. Now, it took me a while to figure that out, or a way of saying that when I first tackled this question, okay? And there comes a point where that may be something that's beyond certain people's ability. So again, I would, if you didn't have an answer, make up an answer, because you will need that later on to solve or to do some of the later parts. Okay. Now next is F. So the number of black triangles in the nth pattern is given by the formula Bn. Okay, equals 1/2 times n squared plus 3/2 times n plus c. Now they're asking you to find the value of c. So technically, as it stands, there's an unknown. The n is unknown and the c is unknown. So we're asked to find the value of c. There's 3 unknowns, can't solve it. Okay, we need more information. Well, the first thing I'd say is, well, you can pick any value of n, because this should work. It's a generalized formula for any value of n. So pick a value of n. Okay, this is the trick here, right? I'm picking 1 because 1 is easy to calculate. So b of 1 equals 1 over a half times 1 squared plus 3 over 2 times 1 plus c. So put that through, I end up with half plus 3 over 2 plus c. So b1 equals 2 plus c. Okay. Now, I know in the first n, so at n equals 1, I know there are 3 triangles. So I actually do know b of 1. I know the number of black triangles is 3. So that's why I can swap this. 3 equals 2 plus c. And that's the equation of 1 unknown. I can solve it very easily. Bring the 2 across. What was added on the right becomes subtracted on the left. Do that calculation. 3 take 2 is 1. Now, that's, I would argue that's coming close to an honours level question in a sense. But they are expecting you to be able to handle this level of algebra and problem solving a little bit more. So it's not beyond the realms of the past level. But without practice, if you've seen this before, these sort of things can be easy. If you click what's happening. If you don't, you could have a very, very bad day. Now, if you put any value of n into that without even knowing what the hell you're doing, okay? So I say sometimes with a formula, if you're given the formula, just throw a number in. They're going to assume you put in an n value for a reason, and they most likely will give you the attempt. This question is worth 5b, so there's a jump of 0 to 3 to 5. If you get the attempt, that's 3 marks out of 5. For a question of that complexity, I take that as a win. Okay, so that's part F. Now part G, this one I remember doing before. It'll drive you to distraction. I'm already knackered, and we're not even finished yet. So use your answers to part E and F above to find a formula for the number of white triangles in the end pattern. Okay, so I'm just going to go to the answer I built in here. So the number of black triangles, okay, plus the number of white triangles equals the total number of triangles. Okay, that's a fair statement. I know that the number of black triangles is given by this function. The number of white triangles, okay, I know that the total number of triangles is this one here. This one and this part we were given in the previous parts. So once you cop that statement is valid, okay, you're looking along going, well, I don't know n and don't know wn, number of white triangles. So there's a problem here, okay? I would just say keep going, okay? Now, if you do keep going, you're going to end up in a situation whereby you can move everything to one side. So I'm leaving the white, the wn on one side, moving the half n squared across, the plus 3 over 2n across the equal, and the 1 across. All the signs will change on those 3 terms, and all become negative going across the equal. So I've represented that there as I'm taking away that from the right hand side. Now, because I've done it that way, I need to just change the sign, so I've done that in the next step. So they all become minus. Then I take them away, so n squared, take away a half n squared, leaves a half n squared. Okay. I have an apple, I take away half of it, I still have half an apple left. 2n take away 3 over 2n is the same thing as minus a half, should be positive. 2 take away 1.5 is a half n squared. I must be wrong there in the answer. Okay, and the 1 take away 1 is 0. And I can change that. I can just go and quickly get the marking scheme and just double check it. And see now, 2015 marking scheme. So paper 1, 7. This is the last paragraph. 7. That's not the answers. It's just the instructions for the grader. Apologies for this extra delay. So that's the last one there. Yeah, okay, I was wrong. When I took 2, take away 1.5, I should have got a half. My bad. Okay, so that should be a positive. Now, if I had made that mistake on the real thing, you've done an awful lot of work to lose. You'd have jumped back one step. So I would have got the high partial, which, yeah, I lost one mark, but that's the way it goes. So this G, oh, there's more. Okay. So this last part, H, one particular pattern has a total of 625 triangles. Find the number of black triangles and the number of white triangles in that pattern. Okay. So I know that the total number, okay, equals 625. So I have my statement for the total number of triangles. I'm putting the fact that I now know that that total number is 625. And I can solve this by bringing the square across the equal. Becomes the square root of 625. And leaves the n plus 1 on its own. 625, square root of 65 is 25. Bring the 1 across, it was added on the right, becomes subtracted on the left, and you end up with 24. So 24 equals n. So it's the 24th pattern. Now, I could go back and count up 24 black, whatever. That's one way of doing that last part here. But if I use the formula I worked out, or which I was given, and put the 24 in instead of n, I can work out what the number of black triangles is. The calculation I did here, use the calculator, is 325. That's that. Now, the Wn, the number of white triangles, is given here. You have that from the previous part. Now I've cropped it to half, so it's actually fixed here. And again, if I'd used a half n squared minus a half n, the answer I got wrong on the previous part, it would have been accepted as fully correct in this part. So that's not too bad. Put the 24 in again instead of n in this statement, and I calculate it out to be 300. So does it make sense? Because this total number here, 300 plus 325, should add to 625, and it does. So you're fairly sure you're correct. Now, this should be the end of question 7. Don't know about you, but I am absolutely exhausted. And I'll stop it there and